Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2015. So let's get started. First problem, what is the value of 2 minus negative 2 to the negative second power? So it's 2 minus negative 2 squared over 1, and negative 2 squared is 4. So it's 2 minus 4, so it's 2 minus 1 over 4. So this is 8 minus 1 over 4 equals 7 over 4. The answer is C. Number 2. Marie does 3 equally time-consuming tasks in a row without taking breaks. She begins the first task at 1 p.m. and finishes the second task at 2:40 p.m. When does she finish the third task? Okay, so for her to do 2 tasks, it takes 1 hour, 40 minutes, equaling 100 minutes, right? So for 3 tasks, then she will take 100 times 3 over 2, which is 150 minutes, which is 2 hours and how many minutes? 2 hours 30 minutes, right? And so she began at 1 p.m. and it took 2 hours and 30 minutes to finish all 3, so it means that she would finish at 3:30 p.m. The answer is B. Number 3, Isaac has written down one integer 2 times and another integer 3 times. The sum of the five numbers is 100 and one of the numbers is 28. What is the other number? Okay, so we have one integer 2 times, so 2a plus 3b equals 100, and 1 of a or b is 28. And so for the other number to be assured and like a positive integer, then b should be 28, right? And so a equals 100 minus 3 times 28 all over 2. This equals 100 minus, 84 over 2. This is 16 over 2. This is 8. So the answer is A. Number 4, 4 siblings ordered an extra large pizza. Alex ate 1/5, Beth 1/3, and Sarah 1/4 of the pizza. Dan got the leftovers. What is the sequence of the siblings in decreasing order of the part of pizza they consumed? Okay, so let's make 1/5, 1/3, and 1/4, all with a common denominator. Then we can calculate how much Dan got. So Alex ate 1 over 5, which is 12 over 60. Beth ate 1 over 3, so that's 20 over 60. 20 over 60, and Cyril got 1/4, which is 15 over 60, and so Dan got 60 minus 20 minus 12 minus 15 over 60, which is, 20 minus 7, so it's 13 over 60, right? So it's 13 over 60, and it said in decreasing order, so the person who ate the most first, so it's Beth, and then Cyril, and then Dan, and then Alex. So it's B, C, D, A. The answer is C. Number 5, David, Higmet, Jack, Marta, Rand, and Todd were in a 12-person race with six other people. Rand finished 6 places ahead of Higmet. Marta finished 1 place behind Jack. David finished 2 places behind Higmet. Jack finished 2 places behind Todd. Todd finished 1 place behind Rand, and Marta finished in 6th place. Who finished in 8th place? Okay, so we have 12 people. 7, 8, 9, 10, 11, 12, and 6th place, and this is 8th place. So Marta finished in 6th place, and Marta finished 1 place behind Jack, so Jack's 5th place, and Jack finished 2 places behind Todd, right? So Todd is over here. Yeah, so Todd is here, and Todd finished 1 place behind Rand, and Rand finished 6 places ahead of Higmet, so Higmet would go here, and David finished 2 places behind Higmet, so it's like this. Who finished in 8th place? It's Higmet. The answer is B. Number 6, Marley practices exactly 1 sport each day of the week. She runs 3 days a week, but never on 2 consecutive days. On Monday, she plays basketball, and 2 days later, golf. She swims and plays tennis, but she never plays tennis the day after running or swimming. Which day of the week does Marley swim? Okay, so there are 7 days in a week. So here's the 7 days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. On Monday she plays basketball, and 2 days later golf. So she plays golf on Wednesday. She swims and plays tennis, but she never plays tennis the day after running or swimming. Okay, so for the 5 slots left, there are only swimming, tennis, and running left. But then since she never plays tennis after running or swimming, then tennis must go here or here. And so let's see what happens when tennis goes here, right? And so if tennis goes like that, then she runs 3 days a week, but never on 2 consecutive days. But then 3 of these have to be filled with running, but then running it can't meet the conditions. So so that means Marley will play tennis after playing golf. So golf is after golf, so this is tennis, and she runs never on 2 consecutive days, so it would be she would run here and then run here and run here, and so that would mean she swims on Saturday. So the answer is Saturday. It's E. Number 7, consider the operation minus the reciprocal of defined by a rhombus b equals a minus 1 over b. What is 1, 2, 3 minus 1, 2, 3? Okay, so first of all, 1 diamond 2, that's 1 minus 1 over 2, that's 1 over 2, and 1 over 2 minus 1 over 3, that's what this is, which is 1 over 6, right? And this one, it becomes 2 minus 1 over 3, which is 5 over 3, right? And 1 minus the reciprocal of 5 over 3, so it's 1 minus 3 over 5, so it's, what is it, 2 over 5, and you subtract these two, so it's all over 30. So it's all over 30, and it's 5 minus 12, so the answer is negative 7 over 30. So the answer is A. Number 8, the letter F shown below is rotated 90 degrees clockwise around the origin, then reflected in the y-axis, then rotated a half turn around the origin. What's the final image? Okay, so we have this letter F, right? This letter F, and it's rotated 90 degrees clockwise around the origin. So clockwise is this way, so like this, right? And then it's reflected in the y-axis, so it will go like this, and then it's rotated a half turn around the origin, so it will go around, so that will become like this, right, like that. And so this will be our final image. The answer is E. Number 9, the shaded region below is called a shark's fin falcata, a figure studied by Leonardo da Vinci. It is bounded by the portion of the circle of radius 3 and center 0, 0 that lies in the first quadrant, the portion of the circle with radius 3 over 2 and center 0, 3 over 2 that lies in the first quadrant, and the line segment from 0, 0 to 3, 0. What is the area of the shark's fin falcata? Okay, so here is one very, very handy tip that you might know or you might not have known, and if you didn't know this, then this is a great opportunity to know this. If there are, if you have a quarter circle of length of radius 2a, and if you have a full circle with radius a, then they have the same area, right? Because if you calculate this one, then this becomes 1/4 times 2a squared pi, which is pi a squared, and the area of this is also pi a squared, right? And so we know that by application, this quarter circle is equal to one circle like that, right? And since this is 1/2 of this circle, right, then we know that the area of this shark's fin falcata, this is equal to just 1/2 of the circle, right? And so this equals this area, right? And so all we have to do is get to the area of this semicircle. And so now what we do is we mark the center, and this would be 3 over 2, right? And so it's 1/2 because it's a semicircle times 3 over 2 squared pi. So this is all over 8 and 9 pi. So 9 pi over 8, the answer is B. Number 10, what is the sign and units digit of all the odd negative integers strictly greater than negative 2015? Okay, so for all the odd negative integers that are greater than negative 2015, so we have minus 2013, minus 2011, minus 2009, all the way to negative 7, negative 5, negative 3, and negative 1, right? And so what we need to do is first we have to figure out the sign, whether it's negative or positive. And so if we add 1 to all the all the terms here, it becomes 2, 4, 6, 8, all the way to 2014. And if we divide that by 2, that becomes 1, 2, 3, 4, all the way to 1007. And so that way we can know that there are 1007 terms in this whole sequence, right? And so 1007 negatives is also equal to 1 negative, right? And so it's a negative number, so B and D are out. And since since they're all supposed to be all negative integers, of course it can't end with a 0, so this is also wrong. And since it has 5 in it, of course it ends with a 5 because it must be a multiple of 5 and it can't end with a 0. So it ends with a 5 and it's a negative number. The answer is C. Number 11. Among the positive integers less than 100, each of whose digits is a prime number, one is selected at random. What is the probability that the selected number is prime? Okay, so for each digit to be a prime number, then we have only four numbers: 2, 3, 5, and 7. Those are the only one-digit prime numbers, right? And so first of all, the selected number can be one of these 4. So obviously we have 4 possibilities right there. And combinations of these that are also prime numbers. So 10's digit and 1's digit, we can do 2, 3, 5, 7, and 2, 3, 5, 7, right? But then for here, the 1's digit cannot be 2. So the 1's digit cannot be 2 because then that would be an even number, so that would not be prime. And also the 1's digit cannot be a 5 because then that would be a multiple of 5. So that also cannot happen. And so let's start. So if 3 is the 1th digit, is 23 a prime number? Yes. Is 33? No. Is 53 a prime number? Yes. Is 73 a prime number? Yes. And for 7, is 27 a prime number? No. Is 37 a prime number? Yes. Is 57 a prime number? No, because it's divisible by 3. And is 77 a prime number? No. So we have 4 combinations. So it's 4 plus 4, right? So 4 from 2, 3, 5, 7, and 4 from the 4 combinations. So it's 4 plus 4 over, and then we have 4 possible because getting 2, 3, 5, or 7. And we have 16 more possible because of 2, 3, 5, 7, 2, 3, 5, 7. So it's 4 times 4, so it's 16. And so this is all 8 over 20. And if we divide by 4, then that will give us 2 over 5. So the answer is B. Number 12. For how many integers x is the point x, negative x inside or on the circle of radius 10 centered at 5, 5? So let's first draw a diagram. So this will be our circle of radius 10 centered at 5, 5. So this is 10 and this is 10. And for the point to be x, negative x, then this is just the same as saying y equals negative x, right? Because this is supposed to be x, y, but y is replaced with negative x, so it's the line of y equals negative x. And so for that to happen, we need this line, right? This line that goes through, and so here it would meet, and here it would meet. It's supposed to meet at 5, negative 5, because that's also a point on y equals negative x. Right, and so for how many integers x is the point x, negative x inside or on it? Okay, so we have all the x's from -5 up to 5, because -5, 5, and then all the integers like the 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? And so we have everything from -5 to 5. These are 11 integers, so the answer is A, right? So number 13, the line 12x plus 5y equals 60 forms a triangle with the coordinate axes. What is the sum of the lengths of the altitudes of this triangle? Okay, so first we have a coordinate plane with the line this, and so let's make this line like that. It would be like this, right? And so since it's 12x plus 5y equals 60, then the x-intercept is 5 and the y-intercept is 12, right? And so this length will be 13, right? And so what is the sum of the lengths of the altitudes? So the altitudes is this length and this length and this length when this is 90 degrees, right? So we have 12 altitude, we have 5 altitude, and we finally need to compute this length. And that length is just, let's say this is x, 13 times x over 2. This is 12 times 5 over 2 because they're both the area of this right triangle. And so if we take out divided by 2, then x would equal 12 times 5 over 13, which is 60 over 13, right? And so plus 60 over 13, right? And so this is 17 plus 60 over 13, right? And even before we just multiply 17 and 13 together and add 60 to it, take a look at the answer choices, because the only choice with it having a denominator of 13, that's E. And so obviously the answer can't be anything other than E. The answer is E. And if you do want to compute this, try it. It does become 17 times 13 equals 221. So 221 plus 60, that gives you 281. The answer is E. Problem number 14. Let A, B, and C be 3 distinct one-digit numbers. What is the maximum value of the sum of the roots of the equation? This, right? Okay, so what we can do is we can take out x minus b, right? So that will give us, this will give us x minus b times 2x minus a minus c. So our roots will be b and a plus c over 2, right? And so the sum of these roots would be b plus a plus c over 2, which would be a plus c plus 2b over 2, right? And for this to be the maximum value, and a, b, and c are 3 distinct one-digit numbers, then that means b would have to be the largest one-digit number possible, and so b would equal 9. And a and c would equal the next largest one-digit number, so a and c equal 7 and 8. And so if we put those in, that gives us, it's all over 2, and a plus c, so 7 plus 8 is 15, plus 2 times 9 is 18, so this is 33 over 2. 33 over 2, which is 16.5, so the answer is D. Number 15. The town of Hamlet has 3 people for each horse, 4 sheep for each cow, and 3 ducks for each person. Which of the following could not possibly be the total number of people, horses, sheep, cows, and ducks in Hamlet? Okay, so we have people, horses, sheep, cows, and ducks. And it has 3 people for each horse, so 1 person equals 3 horses, 4 sheep for each cow, so cow is 4 sheep, and 3 ducks for each person, so ducks is 3 people, which equals 9 horses, right? And so we have 3 horses, 1 horse, 1 sheep, 4 sheep, and 9 horses. And so if we add these up, then that gives us 13h plus 5s, right? And so we have to find a number that is not a multiple of 5 plus a multiple of 13. And let's look at a first. What can a be? If h is 2, then 13h would be 26, and if we add a multiple of 5 to it, then that would get 41, so 41 is not the answer. And for 47, h, yes, so the one-digit values, so the first-digit values have so the first-digit values have to be 7 or 2, right? Because with five s's in influence, then the first digit of 13h would be 7 or 2, right? And first of all, 2 is not plausible right now, because if 13h were to have the first digit 2, then that means it would be 13 times 4, which is 52, and 52 is already greater than 47, so that's not plausible. And also, if the first digit were to be 7, then that means 13 would have to be multiplied by 9 to get the first digit 7. So both of these are not possible. So this is an impossible way. So the answer is B. Number 16, Al, Bill, and Cal will each randomly be assigned a whole number from 1 to 10 inclusive, with no two of them getting the same number. What is the probability that Al's number will be a whole number multiple of Bill's and Bill's number will be a whole number multiple of Cal's? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have Al, Bill, and Cal, right? And no two of them has to get the same number, and since Al's number has to be a whole number multiple of Bill's and Bill's number also has to be a whole number multiple, then we see that Al's number needs at least one non-one factor, right? Yeah, actually at least two non-one factors, right? At least two non-one factors. And so that gives us the possible values for Al's number, which is 1 can't be it, 2 can't be it, 3 can't be it, 4 is possible, 5 no, 6 is possible, 7 no, 8 is possible, 9 is possible, and 10 is possible, right? And so if Al's number is 4, so if Al's number is 4, then Bill's number can be 2, and so Cal's number will be 1, and Bill's number can't be 4 because they can't have the same number, and Bill's number can't be 1 because then C would have to be 1 and they can't have the same number, right? And also by the same reasoning, if Al's number is 6, then Bill's number can either be 2 or 3, and in both cases Cal's number will have to be 1. And if Al's number is 8, Bill's number can be 2 and Cal's number can be 1. Or Bill's number can be 4 and Cal's number can be 1, or Bill's number can be 4 and Cal's number can be 2. All of these work, right? And if Al's number is 9, Bill's number can be 3 and Cal's number can be 1. This is the only way. And for 10, Bill is 2, Cal's 1, or Bill is 5 and Cal is 1. And so this gives us 1, 2, 3, 4, 5, 6, 7, 8, 9 possible ways, right? So we have 9 ways, and all that over how many total possibilities? Since Al, Bill, and Cal has to get one number from 1 to 10 with no two of them getting the same number, so it's 10 times 9 times 8, right? So this will be 720, but we don't have to simplify that because we see that these two get cancelled out. So this is 1 over 80. The answer is C. Number 17. When the centers of the faces of the right triangular prism shown below are joined to create an octahedron, what is the volume of the octahedron? Okay, so let's try to connect the centers. And so that will be our octahedron. And for the volume, first we notice that this is made up of two rectangular based pyramids, right? And they will be this pyramid right here, and the bottom pyramid, which is the one that's like right below here, right? And so we have 2 of those same pyramids, and so what we can do is we can multiply by 2 the first pyramid, right? And it's 2 times, and then to get the first pyramid we have to get the square base area, right? So this is the area, and it's a rhombus with diagonals 5 and 4, so that gives us area 10. And then the height is like it's 1/2 of the height of the rectangular prism, so it's 3 over 2. And then we have to do 1 over 3 to it because it's a pyramid, right? And so then these will all cancel out, and the answer will be 10. The answer is B. Number 18. Johan has 64 fair coins. He flips all the coins. Any coin that lands on tails is tossed again. Coins that lands on tails on the second toss are tossed a third time. What is the expected number of coins that are now heads? Okay, this is quite easy. There's 64 coins, and then flipped. Then 32 will be heads and 32 will be tails. And so since 32 lands on tails, it's tossed again. 16 on heads, 16 on tails, it's tossed again. 8 on heads, 8 on tails. And so what is the expected number of coins that are now heads? 32 plus 16 plus 8, that would be 64 minus 8, which is 56. So the answer is D. Number 19, in triangle ABC, C is 90 degrees and AB equals 12. Squares ABXY and ACWC are constructed outside of the triangle. The points XYZ and W line on a circle. What is the perimeter of the triangle? Okay, so if we make this into a diagram, then we will get something like this, right? And so this is our picture. So, so C is a right angle. C is a right angle like this. And these are squares ABX. These are squares ABXY and ACWZ. And so, yeah, so, and we also can see that the center of line AB will be the center of the circle, right? And now what we have to get is the perimeter of the triangle. And so we know that AB is 12, so this much is 6. Let's put this in 6 and 6. And what we can do is we can draw a midpoint line like that to BC and AC, right? And so if we do that, this is what we get. And so let's say that these lengths are half of BC is A, so there will be 2 A's, and half of AC is B, so there will be 2 B's, right? And so using the fact that the points X, Y, Z, and W lie on the circle, we can connect Y and the center and W and the center, right? And both will be the same length, right? And in fact, they will be the same triangle. They will be congruent. No, sorry, actually, they won't be congruent, but they will have the same length of the hypotenuse, right? And since this is 6 and this ABXY is a square, that means AY is 12, right? And so by that we can know the length of the hypotenuse, and by the Pythagorean theorem we get 6 root 5. That means this length is also 6 root 5, right? And also if we zoom in, since this is B, so AC is 2B, and since ACWC is a square, that means WC is also 2B, right? So WC is 2B, and since half of AC is B, that means this is also B, right? And so this much is also B. And so now we can focus on this triangle right here. This and W, and this. And so that will also be a right triangle, right? And now we can use the Pythagorean theorem. So what we get is 6 root 5 squared, that's the hypotenuse squared, equals B squared, this much, B squared plus A plus 2B squared, right? And so this is, sorry, not to the fifth power squared, and so that gives us A squared plus 4AB plus 5B squared, right? So 6 root 5 squared, so 36 times 5. So 36 times 5 equals A squared plus 4AB plus 5B squared, and by these and by this triangle, actually by this triangle, since it's also a right triangle, we can see that A squared plus B squared. So by this triangle, A squared plus B squared equals 36, right? And so into this 36 we can put A squared plus B squared. So if we do that, A squared plus B squared times 5 equals A squared plus 4AB plus 5B squared. We can see that the 5B squared cancel out, and if A squared goes this way, then 4A squared equals 4AB, and that gives us A equals B. And so since A equals B and A squared plus B squared equals 36, using these two things we can say that then we can know that A is 6 root 2. No, A is 3 root 2 and B is also 3 root 2, right? And so what is the perimeter of the triangle? And so the perimeter of triangle ABC, this was 12 plus 2A plus 2B. And since A is equal to B, this is 12 plus 4A. Since A is 3 root 2, this is 12 plus 12 root 2. So the answer is C. Problem number 20. Erin the ant starts at a given corner of a cube and crawls along exactly 7 edges in such a way that she visits every corner exactly once and then finds that she is unable to return along an edge to her starting point. How many paths are there meeting these conditions? Okay, so let's first draw a cube like this. These will be the visible parts and these will be the invisible parts, right? And so let's say that Erin starts at this corner. So Erin starts at this corner, and when she crosses along all 7 edges, then she cannot be here, here, or here, right? And so where she can be is this point, this point, this point, or this point, right? But then if we see if we see these points all have kind of the same kind of characteristics, right? Because they are all 2 edges away from the starting point, right? And for Erin to crawl along all 7 edges in a way that she visits every corner exactly once, then going to these going to these points at the end of her journey, that is impossible, right? And so we yes, and so Erin cannot end at these 3 points, right? And so Erin must start at one point and end at the exact opposite point, right? Yeah, and so first what we have and so we have to get the number of paths that meet these conditions. And first of all, to go from the starting point, any way that Erin chooses, it is all the same, right? Because she can choose either this way or this way or this way, and they are all the same, right? Because if you rotate the cube a little, then it will just be the same thing. So it's 3 possible ways, and we can just and the probabilities after any of those choices, those will be equal, right? So we can just say 3 and just choose a random and just choose a random path. Let's say she chose this one, and then she has 2 choices, this one or this one. But then also right here also it doesn't really matter, right? Because whether she goes this way or whether she goes this way, it is symmetric, right? And so she has 2 choices again, and let's say that she just chose this one, and that would not have an impact on the total probability, right? And lastly, Erin can and lastly, we find that now we only have 1 choice for every other we have 1 choice for every next path, right? So since Erin can't go here right away, she has to go here, and since she can't go here, she has to go here. Since she can't go here, she has to go here, and since she can't go here, she has to go up, and since she has traveled here before, she must go to the last point, right? And so after these 6 choices, then we only have 1 choice after that. So 3 times 2 times 1 is equals 6. So the answer is 6 choices, it's A. Problem number 21. Cozy the cat and Dash the dog are going up a staircase with a certain number of steps. However, instead of walking up the steps one at a time, both Cozy and Dash jump. Cozy goes 2 steps up with each jump, though if necessary he will just jump the last step. Dash goes 5 steps up with each jump, though if necessary he will just jump the last steps if there are less than 5 steps left. Suppose Dash takes 19 fewer jumps than Cozy to reach the top of the staircase. Let S denote the sum of all possible number of steps this staircase can have. What is the sum of the digits of S? Okay, so first of all, if Cozy took A jumps, right? If Dash took A jumps, then that means the number of steps on the staircase would be 5A, or 5A minus 1 plus a certain number from 1 to 4, right? And similarly, Cozy, if Cozy jumps B times, so if Cozy has B jumps, then the number of steps will be 2B or 2B minus 1. 2B minus 1, right? So let's try to get, and so one of these two will be equal to one of these two, right? And so first, let's try the case where 5a minus 1 plus something, 5a minus 1 plus something equals 2b, 2b no, just 2b, right? Let's try these two combination first, right? And other than this, there can be 5a minus 1 plus something equals 2b minus 1, or I'll bring this a little bit down. So there could be where 5a minus 1 plus something is 2b minus 1, or just 5a could equal 2b, or just 5a could equal 2b minus 1, right? But then and we know that Dash takes 19 fewer jumps than Cozy, right? So A is 19 less than B, right? So B equals 19 plus A. That's also what we have to keep in mind, right? And so if we do this, then this will give us that since B is 19 plus A, 5A minus 5 plus something equals 19 plus A equals 2A plus 38, right? And so 3A equals 43 minus something. So 3A equals 43 minus something, right? And this whole thing has to be a multiple of 3, right? And so for that to happen, A can be, no, so for that to happen, the square can be 1 to make this whole thing 42, or this can be 4, right, to make this whole thing 39, and they are both multiples of 3, so they both work. And so if the square is 1, then 3a equals, what is it? 3a equals 42, so a equals 13, right? No, a equals 14. And so B would be 19 plus A, which is 33, right? And so in this case, there will be a total of 2B times, so 2B, which is 2 times 33. So this time there will be 66 steps in total, right? And if the square is 4, then 3A would equal, what is it? 3a equals 39, so a would equal 13. A equals 13, so b would equal 13 plus 19, which is 32, and so it's 2 times 32, which is 64. So this is 64. So we can have either 66 or 64 staircases, 4 steps, right? And next case, if this happens, and so for that, 5a minus 5 plus something equals same thing, b equals 19 plus a, so we plug that in here. That is 2a plus 37, and so that will give us 3a equals 42 minus something, right? And so for this one, we need something to be a multiple of 3, and so the only thing from 1 to 4 that is possible is 3, because 42 is a multiple of 3 already, right? And so here 3a will be 39, so a will be 13, and b will be 32, like just before, but then this time the number of steps is 2b minus 1, right? So it's 2 times 32 minus 1, which is 63, so we can have 63 steps right here, right? And as for 5a minus 2, as for 5a equals 2b and 5a equals 2b minus 1, if you do try to get values, you won't get any values, so they will all amount to nothing. So if you want to try that, then you can in your own time. And so just in conclusion, we have 3 possible values of the numbers of staircases, and since s is the sum of all possible numbers of steps this staircase can have, s equals 66 plus 64 plus 63, which is 193, right? And so the sum of the digits of s is what we want. So 1 plus 9 plus 3 equals 13. The answer is 13, it's D. Problem number 22. In the figure shown below, ABCDE is a regular pentagon and AG equals 1. What is FG plus JH plus CD? Okay, so since AG equals 1, this is 1, right? And since AG is 1, this is also 1. JH, it's also 1 because they're all the same length, right? And FG plus JH plus CD, then all we need to know is FG, right? Because if we set FG as X, then this will also be X, and by these ratios, we can also get DC's ratio, right? We can also get DC's length, right? And so, first of all, what we can use is that this ratio and this ratio is equal, and so we can make it so that 1 over X, so AG over FG, this equals 1 plus X over 1, right? And so 1 equals X squared plus X plus 1, no, X squared plus X, and so X squared plus X minus 1 equals 0. And for that to happen, X must be, let's use the quadratic formula, all over 2 and minus 1 plus or minus root b squared minus 4ac, so plus 4. So this is root 5, right? And this can be plus minus, it should be plus, because X has to be a positive number, right? And FG plus JH plus CD. If we see here, then if we draw a parallel line from H, so if we draw a line from H that is parallel to the line JD, and so these two will be parallel, then we can see that this length is also 1, and we can also see that this AFG triangle and this new triangle, they are congruent, and so this will also be 1, right? So this is, no, that will also be X, right? And so FG plus JH plus CD, so FG plus JH plus CD is X plus 1 plus X, right? And this is 2 plus 2X, right? And if we substitute this value into X, then what we get is 2 plus 2X, and then that 2X negates this 2, right? And so that will make it so like root 5 minus 1, right? This gives us root 5 plus 1, so we want this. The answer is D. Number 23, let n be a positive integer greater than 4, such that the decimal representation of n factorial ends in k zeros and the decimal representation of 2n factorial ends in 3k zeros. Let us denote the sum of the 4 least possible values of n. What is the sum of the digits of s? Okay, so first of all, the decimal representation of n factorial has to end in k zeros, but then if something ends in k zeros, then that means there are k combinations of 2's and 5's, right? But since 2's are like basically everywhere, they're in every even number, what it just means that there are k number of 5's, right? So there are k 5's in n factorial. And by the same reasoning, 2n factorial and then 3k zeros, that means 2n factorial has 3k 5's, right? And so if we write out the factors of, and if we write out the multiples of 5, we get 5, 10, 15, 20, 25, 30, right? And so on. But then if we count the number of 5's, we have 1 5 here, 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 we have 2 5's here, and we have 1 5 here, right? And so we need the we need the 4 least possible values of n, and so for that we will first look to n within this first kind of gap, right? And so if n is here, so if n is greater than 5 and less than 10, right, then k would be 1, right? K would be 1, and so 3k 5's, that would mean there are 3 5's, right? And so for there to be 3 5's, it has to be between 15 and 20, and so 15 and 20, right? And so so we need all the values of n that, sorry, this can't be in this has to be 2n because it's 2n factorial. So 2n is between 15 and 20, right? And so we need the values of n that meet these conditions, right? And so we can get n equals 8 because that way both conditions are satisfied, and n equals 9 can do. And we can't do n equals 10 because there's no equal sign, right? So we have 8 and 9 first. And the next is if we consider that n is between 10 and 15, right? We have to do this because it asked for the 4 least possible values of n, and we just had 2 from the first one. And so for 10 and 15, so n is between 10 and 15, right? And for that to be n, then 2n factorial has 2n, then 3k 5s, which means 2n factorial needs 6 5s, right? And so 6 5s means until 25, this is 6 5, so it's between 25 and 30, right? So 2n is greater than or equal to 25, and it's less than 30, right? And so from these ones, what we can get is n can't be until 12, and so n is 13, and n equals 13 works because 13 is in here, and 26 is within here, and 14 also works, and we can't do 15 because there's no equal sign, right? So these are 2 more values, and since we want 4 values, these are all we need. What is the sum of the digits of s? Okay, so s is the sum of the 4 of these possible digits, right? So the s equals 8 plus 9 plus 13 plus 14, which equals 22 plus 22, which is 44. And so the sum of the digits of s, that will be 8. So the answer is 8, it's B. Number 24, Aaron the ant walks on the coordinate plane according to the following rules. He starts at the origin P0 equals 0, 0 facing to the east and walks 1 unit, arriving at P1 equals 1, 0. For n equals 1, 2, 3, and so on right after arriving at the point Pn. If Aaron can turn 90 degrees left and walk 1 unit to an unvisited point Pn plus 1, he does that. Otherwise, he walks 1 unit straight ahead to reach Pn plus 1. Thus, the sequence of points continues P2 equals 1, 1, P3 equals 0, 1, P4 negative 1, 1, and so on, in a counterclockwise spiral pattern. What is P to the 2015th power? Okay, so let's first draw this coordinate plane. And so we have the coordinate plane, and he starts at the origin. This is P0. Let's make it red. This is P0. And facing to the east and walks 1 unit. So this is P1. And for n equals 1 to 3, and so P2 is 1, 1, 3 is 0, 1, and so he goes in this counterclockwise pattern, right? Counterclockwise spiral pattern, as I said here. And so P2 would go here, 3, 4, 5, 6, here's 7, here's 8, here's 9, here's 10, right? And so it will go like this, and it will go on a counterclockwise spiral pattern forever until it like runs out of breath and dies or something, right? And so if we just connect to all of this, this will be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, this is 27, this is 26, this is 25, right? And then here it's all in red, so it's kind of hard to notice, but you can see that this point is 1, this point is 9, and this point is 25, right? And they are all going in this direction, right? And so what we can see is that these are the odd perfect squares, right? And so these are, and so this going to the bottom right, this line is y equals minus x plus 1, right? Y equals negative x plus 1, and then for x equals 1 we have 1, for x equals 2 we have 9, for x equals 3 we have 25, right? So these kinds of values of p, right? So these kinds of p values, let's say, so these values of p would be if this would be like 2x minus 1 squared, right? Because if x is 1, that would be 1 squared, which is 1. If x is 2, that would be 3 squared, which is 9 over here, right? And so on and on like that. And since we need the p-value to be as close as possible to 2015 right here, this is close as possible to 2015. We know that 45 squared equals 2025, right? And so what if 2x plus 1, no, 2x minus 1 equals 45? Then x would equal 23, right? And so that coordinate on the plane would be 23 comma negative x plus 1, right? Y is negative x plus 1, so minus 23 plus 1, so it's negative 22, right? So it's 23 comma negative 22, that's the coordinates, right? But then this is for when it's P 2025, right? And so for P 2015, we need to go 10 steps less, right? 10 steps behind. And so since 2025 would be somewhere all the way here, 2025, then 10 steps back would be going 10 steps horizontally backwards, right? And so that would make the x decrease and the y would stay the same. And so for P 2015, that would be 23 minus 23 comma negative 22, and 23 would have to subtract by 10, so that's 13 comma negative 22. So the answer is D. Number 25. A rectangular box measures a by b by c, where a, b, c are integers, and 1 a, b, c in this inequality. The volume and surface area of the box are numerically equal. How many order triples a, b, c are possible? Okay, so first let's use the condition here. The volume and surface area are equal. So the box would be shaped like this, and this would be like a, b, c, right? And so first of all, we see that ABC, that's the volume, equals the surface area, so it's 2AB plus 2BC plus 2AC, right? And if we divide it all by 2ABC, divide by 2ABC, 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 and 2ABC to everything, then that would give us that 1 over 2 is equal to 1 over C plus 1 over A plus 1 over B. And that is equal to, let's just reorder it in a nice way, 1 over A plus 1 over B plus 1 over C, right? And since A is the least of all of these, and since A is less than B or C, that means that 1 over A plus 1 over B plus 1 over C is less than or equal to 1 over A plus 1 over A plus 1 over A, because 1 over A is bigger than or equal to 1 over B, and 1 over A is bigger than or equal to 1 over C. And so this will be equal to 3 over A. This will be equal to 3 over A, right? And so by this and this coming together, then we can see that A is less than or equal to 6, right? And also, other than this, we have one more kind of clause, that 1 over A plus 1 over B plus 1 over C must be greater than 1 over A, right? Since 1 over B and 1 over C are positive numbers. And so by the same thing, 1 over 2 and 1 over A, that gives us that A is greater than 2, right? And so by these things, we have established the values for A. It can be 3, 4, 5, or 6, because A has to be integers, right? And now, how many order triplets A, B, C are possible? And so what we get now is we have to go back to the original equation, and then we displace 2BC to unite the BC's together, right? And so that will give us ABC minus 2BC equals 2AB plus 2AC. And combining like terms, we get A minus 2 times BC. This equals 2A times B plus C, right? And so now we plug in the possible values for A. If A is 1, no, if A is 3, if A is 4, if A is 5, and if A is 6. Right, so first let's deal with the case if A equals 3, right? And so if A equals 3, then this equation will be 3 minus 2, so it's 1. BC equals 6B plus C, right? And so this will make it so that B minus 6, C minus 6 equals 6 squared, which is 36, right? And so B minus 6 times C minus 6 is 36, and since B is less than or equal to C, then the values for B and C can be 136 or 218. No, sorry. This should be B minus 6 and C minus 6, right? And so this should be 1 and 36 or 218 or 312 or 49 or 66, right? And there are no other ways, right? And so for this, there are 5 possible ways, and so we have 5 possible ways to do it when A equals 3. So this gives us 5 ways. Let's do it in red. And for A equals 4, we have 4 minus 2, so 2bc. 2bc equals 2 times 4, so 8b plus c. And so if we divide by 2, that is equal to bc equals 4b plus c. And so that gives us b minus 4 times c minus 4 equals 16, which is 4 squared. And so if we do the same thing for b minus 6 and c minus 6 like we did before, b is less than or equal to c, right? And so this can be 116 or 28 or 44 and no more, right? Because b has to be less than or equal to 6. And so this gives us 3 possible order triples of A, B, and C. And for when A equals 5, then this gives us 5 minus 2, so it's 3. 3bc equals 10b plus c, right? So that's not very clean. So let's make it so that bc equals 10 over 3 b plus c. So this will give us b minus 10 over 3, c minus 10 over 3. This equals 10 over 3 squared, which is 100 over 9, right? And so, sorry, this should have been changed when we did this one too. This is b minus 10 over 3 and c minus 10 over 3, right? And so they should multiply to become 100 over 9, but b and c also have to be integers, right? And so for this to happen, we need all over 3. We need these numbers to be over 3, and for this value to be less than this value, we have only one solution, right? Because it can't be 10 and 10, because then b and c would not be integers, and it can't be like 4 or stuff like that, because then b and c won't be integers, right? And so our only possible things is 5 over 3 and 20 over 3. And so this gives us the value that b values that b equals 5 and c equals 10, right? So those do meet the conditions. So that gives us 1. That gives us one possibility. And if a equals 6, then a minus 2 equals 4. So 4bc equals 2 times 6, so 12b plus c. So that gives us that bc equals 3b plus c, because we divide by 4 on both sides. And so this gives us the value that b minus 3 times c minus 3 equals 9. And so if we change this, b minus 3 and c minus 3, they can be 1 and 9 or 3 and 3, right? But then see, if b minus 3 and c minus 3 is 1 minus 9, then b would equal 4, right? But then since a is 6, b and c both have to be greater than or equal to 6, right? And if b equals 4, it's not possible. So 1 and 9 is not possible. But then if it's 3, 3, then b and c are both 6 and 6, and so that does meet the conditions, right? And so we also have only one possible for this one. So the total question was how many order triples are possible. We have 5, 3, 1, 1, and if we add them together, the answer is 10. It's B. So that was it for AMC 10 from the year AMC 10B from the year 2015. And thank you for watching.